In the last video, I went over vertical translations, and in this video, I'm going to go over horizontal translations. So again, I want to mention one thing, which is this is just like the horizontal stretches that we did before. This is also a little bit tricky, so you need to sort of pay careful attention to this video. All right, so just like the name suggests, if we're translating something horizontally, it means that it affects the inputs, which means the x's, but not the outputs. So I'm going to explain this via an example. So let's say, for example, I just have an xy. Here's my xy axes, and I just have one point. So let's just say that point is 2, 4. Say that point is 2, 4 right there. So here's my coordinate 2, 4, and this is my entire function. So this function f of x is just simply made up of one point. I don't need a line or anything like that. It's just made up of one point, and that the point, the coordinates of that point, happen to be 2, 4. So let's say, for example, so here's f of x, and like we said, it affects the inputs but not the outputs. So here's f of 2, right? If the input is 2, the output has to be 4, so that's equal to 4. Okay? So a translation simply means a movement, right? So in this case, a horizontal, we're moving things left or right. And it's only obviously going to affect the x's. So let's say for my original function f of x, what I'm going to do is I'm going to translate it to this, f of x plus 1. And remember, like I said before, it affects the inputs but not the outputs. So in other words, if my original output was 4, even if I translate it, the output will still remain as 4. Okay? So what you need to observe, the question now becomes, is what will the value of x be to satisfy, like how will this point of 2 move or translate according to this function? So let's take a look at this. So if this value is 2, which must mean this value is also 2, so they're equivalent. So in other words, x plus 1 is equal to 2. In other words, x is equal to 2 minus 1, which is 1. That's really interesting. So in other words, previously it was a value of 2, the coordinate was a value of 2, but now it has decreased to a value of 1. So in other words, it has moved to the left. Or it has decreased by 1. Or if the value was x equals 2 before, now it's x equals 1. So it must mean it has moved to the left. So we'll say translated left. And this seems a little bit counterintuitive because you might have thought that, oh, it's x plus 1, so maybe it's movement to the right. But no, it's actually quite the opposite. So because we said x plus 1, we need to compensate that by saying it's decreased by 1, so it's translated left by 1 unit. Decreased by 1 unit. I should have said 1 unit. Let's try another example. So let's say, for example, so here's the original point. So f of 2 equals 4. And now I translate it to this function, which is f of x plus 2 is equal to 4. Remember, the outputs stay the same. And if you observe here, this 2 needs to equal to x plus 2. So x plus 2 will equal to 2. And therefore, x equals 0. Whoa, that's really interesting. So the original point was 2, and that has now been shifted to 0. So in other words, we have decreased by 2 units. Or another way of saying this, we have translated again to the left, because originally if x was 2 and it has now moved to 0, well, that must mean it has moved to the left. From 2 to 0 is a left translation. So translated left by 2 units. Let's do one more example now. And once again, just to observe, you might have thought x plus 2 must mean a movement to the right, but it's the exact opposite. It's a movement to the left. Let's do one last example. So let's do, for example, f of 2, which is equal to 4. Again, this comes from the original function. And let's say I translate it to f of x minus 3. And again, the output must remain the same. So if we do this 2 and this x minus 3 should be equivalent. So therefore, x minus 3 is equal to 2. And if we solve for x, we get x equals 5. So what has that done? So if we go from 2 to 5, that's really a movement to the right by 3 units. So it's translated right by 3 units. And that's really interesting. So observe a pattern that's forming over here. When the horizontal translation, when the function says x plus 1, we actually move to the left. So we might, obviously we might associate plus with being positive, so it's to the right. But when it's inside the function, it's to the left. When it's x plus 2, we move 2 units to the left, even though it's plus. And when we have x minus 3, we move translated right. So in other words, it's sort of a counterintuitive principle. So basically, from this, we can develop a rule. So here's the rule. And the rule is such, okay? So again, what we're going to say is let's say some variable a is an element of a positive real number. So in other words, a is just a positive number. That's all what that means. So if we say f of x plus a, this does the exact opposite effect. So in other words, it's a horizontal translation to the left by a units. So for example, if a was 2, it just means that we horizontally translate this function to the left, not to the right, even though it's plus, to the left by 2 units. Let's do the opposite. So what happens when we have a minus? So this would simply mean it's a horizontal translation to the right by a units. So remember the counterintuitive principle. When you see a plus inside the f, it means to the left. When you see a minus inside the f, it means to the right. Let's demonstrate this with an example. So again, this is the example that I've been using throughout. So here are the edge points for this function, which are 1, 2, 2, 4, and 4, 1. So let's say, for example, here's my original function, y equals f of x, and I translate that to y equals f of x plus 2. So once again, it affects the x's, but not the y's. There's nothing outside here, nothing outside the f to affect the y. So first, let's write a description of the transformation itself. So we're going to say there's a horizontal translation to the left. Keep in mind it's to the left. So even though it's plus, it's to the left by 2 units. So it means all the x's are moved to the left by 2. So if this is our original xy table, how will the transformed one look like? Well, if all the x's are being moved by 2 to the left, so it's going to be x minus 2. The y's are not affected whatsoever, so that just remains y. So this 1 minus 2 will become negative 1. 2 minus 2 is 0, and 4 minus 2 is 2. And since y is not affected, that just remains as 2, 4, and 1. And now let's plot these points. So our first point is, let's say it's negative 1 here. So it's negative 1, 2. So that's where it is right there. Then 0, 4. 0, 4 is right there, and 2, 1 is right here. And now let's just connect the dots. So if I connect the dots, say I connect the dots. So there we go, right there. And then that is connected right there. And now let me just label this green one. So I'm going to call this f of x plus 2. So clearly we can see that there's a translation to the left by 2 units, and that is how we do horizontal translations. All right, there's a couple of more things I want to discuss, so I'll see you in the next video.